All right, let's dive in. Today, we're going to trace the path from the tiniest little switch inside your phone all the way up to the giant, messy, beautiful world of information we swim in every single day. We're connecting the bit to the big picture.
So, think about it. You tap on your screen, you click your mouse, and somehow this machine that doesn't speak English, that doesn't think like you, it knows exactly what you want it to do. How? How does that even work? Well, that's the big mystery we're going to solve right now.
To get it, we first have to wrap our heads around two really big ideas, analog and digital. See, our world, the physical world, is analog. It's all smooth and continuous, like the ink physically printed on the page of a book. But a computer's world, that's digital. Everything, and I mean everything, is chopped up into separate little pieces or symbols, just a bunch of zeros and ones. That's the key difference we need to get.
So, here's our game plan for today. We're going to start with those famous zeros and ones. Then we'll see how they magically turn into something that actually means something to us. We'll talk about why quality matters so much. Then we'll look at how we even begin to manage all this info, and finally, what it all means for us, right now, living in this information age.
All right, let's start at the absolute beginning. We're talking about the smallest possible piece of this whole puzzle, the digital atom, if you will.
And that digital atom, it's called a bit. A bit is the simplest thing you can possibly imagine. It can only be one of two things. It's either on or it's off. It's a yes or a no. It's a 1 or a 0. The best way to think about it is just a simple light switch. It's either on or it's off. And here's the wild part. Every single thing your computer does, every photo you see, every song you hear, it all boils down to billions of these tiny little switches flipping on and off at speeds you can't even comprehend.
So how in the world do you count with just on and off switches? Well, we use a system with 10 digits, right? 0 through 9. Computers use a system with only 2, 0 and 1. It's called binary. And by stringing these bits together in different patterns, they can represent any number you can think of. So for us, the number 2 is just 2. But for a computer, it's 010. Our number 4 is their 100. It's a totally different language, but it's a language built on the simplest logic possible.
Okay, so computers have their own language of zeros and ones. Cool. But a giant, endless string of zeros and ones is pretty much meaningless to you and me. So how do we get from that raw code to something we can actually, use?
Just take a look at this. Olympia, Merchant, 81. Paris, Fisher, 45. What is this? It's just a random pile of words and numbers. This right here is a perfect example of what we call data. It's just a collection of raw facts, totally unorganized, and on its own, it's pretty much useless.
Exactly. It's just stuff. There's no context, no structure. For it to mean anything, we have to give it some.
And now, look at that. It's the exact same data, but we've made one tiny change. We added context. We put it in a table and gave it some labels, first name, last name, score. And bam, instantly it all makes sense. Paris Merchant got a score of 81. This is the magic moment. This is the transformation from useless data into valuable information. Information is just data that we've processed to give it meaning. And the way computers pull this off is with a simple but super powerful 3-step cycle. First, you've got input. That's us, entering all that raw data. Second, you have process. This is where the computer does the heavy lifting, organizing, sorting, calculating. And finally, you get the output. That's the useful, meaningful information it gives back to us. Input, process, output. That simple loop is the heartbeat of all computing. Now that little cycle is incredibly powerful, but it has one huge weakness. The quality of what you get out is completely 100% dependent on the quality of what you put in. And this brings us to one of the oldest, wisest, and most important rules in all of computing. Garbage in, garbage out. If you feed a system bad data, messy data, or just plain wrong data, you are going to get bad, messy, wrong information back. It's really that simple. So how does all this garbage even get into the system? Well, it usually happens in a few common ways. You can have a data source error. That's when someone just gives you the wrong info to begin with. You can have a transcription error. That's just a simple typo. Or you could have a transposition error, where you just swap two things around, like typing $51 instead of $15. Any one of these little slip-ups can totally mess up your results.
So how do we stop the garbage before it gets in? We use something called data validation. And trust me, you've seen this a million times. You know when you're filling out a form online and you get that angry red message telling you did something wrong? That's data validation in action. A presence check makes sure you didn't leave a required box empty. A type check makes sure you put a number in the age box, not your name.
A format check makes sure your email address actually has an @ symbol in it. It's the system's bodyguard, basically, keeping the bad data out.
Okay, so now we know how to make good, clean, useful information. Fantastic. But now we have a whole new problem. There's just so much of it. We are drowning in information. So how do we organize and manage this absolute flood of data?
Well, the main tool we use is the database. And don't just think of it as a big digital filing cabinet. It's so much more than that. Think of it like a perfectly organized, super efficient digital library where every single piece of information is cataloged and can be found in a split second.
And it takes a whole team of people to bring these systems to life. You've got the system analyst, they're like the architect, drawing up the blueprints for what needs to be built. Then you have the programmer, they're the builder, the one who actually writes the code to make it all work. And finally, you have the database administrator. Think of them as the head librarian, carefully organizing, managing, and protecting all the priceless information inside.
Now, how does a computer actually find the data it needs? Well, there are two main ways. The old way is called sequential access. This is like an old-school cassette tape. If you want to hear the fifth song, you have to fast forward through the first four. It's slow. The modern way is direct access. This is like your hard drive or a USB stick. You can jump directly to any piece of data you want, instantly. Obviously, it's way, way faster.
So let's zoom out and put all these pieces together. We've got bits turning into data, which turns into information that gets stored in databases. All of these little building blocks have created the world we live in right now, the information age.
So what caused this huge explosion? It was really a perfect storm of technology. Suddenly, powerful computers and phones became cheap enough for almost everyone to have one. The software we use became way more intuitive and easy to use. And our communication networks got ridiculously fast, connecting everything and everyone around the entire planet.
And that foundation has led to these enormous trends that are totally reshaping our world. You have the Internet of Things, or IoT. That's all of our physical devices, from smartwatches to refrigerators, all connected and constantly creating data. That endless stream of data created what we call big data, and the only way to possibly make sense of that much data is with artificial intelligence, or AI, which can see patterns and find insights in seconds that would take a human a lifetime.
And that brings us to one last and maybe the most important question. We are swimming in an ocean of information, more than at any point in human history. But just being surrounded by it isn't enough. So let me ask you, in an age of endless information, how literate are you?
Because being truly information literate today is about so much more than just being good at searching online. It's about credibility, really thinking about where your information is coming from and if you can trust it. It's about data privacy, respecting your own privacy and the privacy of others. It's about intellectual property, not stealing other people's work. And it's about being able to pull information from all over and organize it in a way that makes sense. Understanding that journey from a single bit to this global network is the first step. The next step is learning to navigate it with wisdom. Thanks so much for tuning in.